now on Night Beat, some scary moments for a driver in the South Bay after his new Tesla mysteriously catches fire.
Driver got a notification for low tire pressure. About 2 hours later, it caught on fire.
Electric vehicles were supposed to mark the beginning of a safer, cleaner future. Cars that hum quietly, run efficiently, and never see a gas pump again. But beneath all that futuristic engineering lies a hidden danger that has left even the most loyal EV fans uneasy. Fire. Not from the engine, but from deep inside the battery itself. When lithium-ion cells overheat or get damaged, they can trigger what experts call a thermal runaway, a chain reaction so intense that it melts metal, burns for hours, and sometimes reignites even after being put out. These incidents aren't just rare flukes. They've happened in driveways, garages, and even on highways. From household names to luxury newcomers, some electric cars have developed a disturbing reputation for catching fire too easily. Here are 15 electric vehicles that turned innovation into ignition and left safety regulators scrambling for answers. Number 15. Tesla Model S. When the Tesla Model S debuted, it was hailed as the pinnacle of electric luxury. Fast, sleek, and revolutionary. But with great innovation came an unsettling pattern of fiery incidents that shook public confidence. Over the years, multiple Model S vehicles have burst into flames, sometimes after high-speed crashes, other times while parked and unplugged. These weren't simple fires. They were intense, chemical infernos fueled by lithium-ion cells that can reach temperatures exceeding 1,000 degrees Fahrenheit. The problem traces back to the enormous energy density packed inside Tesla's battery modules. A single puncture, short circuit, or cooling failure can cause what's known as thermal runaway, spreading heat uncontrollably between cells. In several cases, fires reignited hours later, even after firefighters had extinguished the blaze. Tesla's engineers implemented additional shielding, updated software, and improved coolant circulation, but the damage to reputation had already begun. The National Highway Traffic Safety Administration, NHTSA, has investigated multiple incidents involving the Model S. Although Tesla defended its vehicles as statistically safer than gas-powered cars, the public perception was different. Viral videos of smoldering Teslas on highways fueled panic. Some insurers even began increasing premiums for owners in fire-prone regions. In response, Tesla rolled out over-the-air updates to adjust charging limits and cooling algorithms, showing how software could manage a mechanical risk. But critics argue that design, not software, is the real issue. The Model S uses thousands of small cylindrical cells, a brilliant engineering feat for performance, yet a nightmare when things go wrong. Even a single failure can cascade like falling dominoes. Despite the headlines, the Model S remains one of the most advanced EVs ever built. Still, its legacy is marked not only by record-breaking acceleration, but also by unforgettable flames. A reminder that in the race for innovation, safety sometimes trails behind speed. Number 14. Chevrolet Bolt EV. When General Motors launched the Chevrolet Bolt EV, it was praised as the everyman's electric car. Affordable, practical, and proof that mainstream America could finally go electric. But behind its friendly looks and decent range was a ticking time bomb that would become one of the largest battery-related recalls in automotive history. Between 2017 and 2022, reports began surfacing of Bolts catching fire while parked, plugged in, or even unplugged. The culprit was eventually traced back to manufacturing defects in the battery cells supplied by LG Chem. Two critical flaws, a torn anode tab and a folded separator, could combine to trigger a short circuit inside the battery, leading to thermal runaway. Once ignited, the fires were nearly impossible to extinguish, often reigniting hours later. GM was forced to issue multiple recalls, eventually deciding to replace every single battery pack in all affected bolts. The company advised owners not to park their cars indoors, not to charge them overnight, and not to let the battery drop below 70 miles of range, effectively making the car impractical for normal use. It was an embarrassing situation for a company trying to lead the EV revolution. The total cost of the recall exceeded $2 billion, most of which LG Chem agreed to cover after months of negotiation. Production of the Bolt was temporarily halted, and public trust took a major hit. Even after replacements, some owners reported new software glitches and charging irregularities, further fueling doubts about long-term reliability. For a car designed to bring electric mobility to the masses, the Bolt EV ended up doing the opposite, reminding people that even affordable EVs can pose serious risks. GM has since pledged to redesign future batteries with better safeguards, but the shadow of those fiery garage incidents still lingers. The Bolt may have proven that electric cars could be practical, but it also proved that one small battery flaw can burn through billions. Number 13. Hyundai Kona Electric. The Hyundai Kona Electric was supposed to be a quiet triumph, a stylish, compact SUV offering impressive range and performance without the Tesla price tag. But by 2020, it had become one of the most infamous names in EV fire history. Across South Korea, Canada, and parts of Europe, dozens of Kona Electrics went up in flames, some while charging, others parked idly in garages. In one alarming case, an apartment complex had to be evacuated after a Kona ignited in an underground parking lot. Investigations revealed that the culprit was again linked to faulty battery cells manufactured by LG Energy Solution. Tiny manufacturing defects, such as folded separators and misaligned electrodes, could lead to internal short circuits. Once triggered, the heat inside the tightly packed lithium-ion battery cells spread rapidly, igniting the entire vehicle within minutes. The fires burned hot enough to melt nearby cars and infrastructure. Hyundai initially tried to downplay the issue, issuing a limited recall. But as incidents multiplied, regulators demanded a full investigation. The result? A recall of over 75,000 Kona electric units worldwide. Hyundai's engineers had to replace entire battery packs, a move that cost the company nearly $900 million. Even then, many owners reported long wait times, software problems after the replacement, and growing distrust of the brand's electric lineup. What made the Kona fires particularly troubling was how unpredictable they were. Unlike gas cars, which usually ignite after collisions, these EVs caught fire when stationary and unattended. This unpredictability eroded public confidence in electric safety, especially in densely populated areas. In the end, Hyundai shifted focus to its newer Ioniq lineup, which uses a completely redesigned battery architecture. Still, the Kona Electric remains a cautionary tale in the EV industry, a reminder that even the most efficient design can go up in smoke when microscopic flaws are left unchecked. Number 12. Audi e-tron. When Audi entered the EV market with the e-tron, it was meant to showcase the brand's mastery of engineering, a luxury SUV that combined German precision with futuristic power. But not long after its release, reports of fires and recalls began clouding that image of perfection. The first major red flag appeared in 2019, when Audi voluntarily recalled over 1,600 e-tron units due to a risk of moisture entering the high-voltage battery compartment. At first glance, that might sound minor, but inside an EV battery, even a few drops of water can spell disaster. Moisture compromises insulation, corrodes internal components, and can trigger short circuits that lead to thermal runaway. In several instances, vehicles displayed warning lights or refused to charge properly. Early signs of something much more dangerous brewing below the floor. In some cases, Audi owners reported the distinct smell of burning plastic or smoke during charging sessions. Audi's engineers traced the problem to a faulty battery seal. When exposed to heavy rain, high humidity, or improper assembly, small gaps allowed water to reach sensitive electrical areas. Rather than risk catastrophic fires, Audi ordered dealers to inspect and replace affected parts. While the company managed to contain most issues before widespread damage occurred, the incident tarnished its image as a brand known for reliability and refinement. What set the e-tron's troubles apart was that these fires weren't caused by aggressive driving, collisions, or charging errors. They stemmed from environmental factors and build precision. Owners paying premium prices expected better. Although later models received improved sealing and better battery management software, Audi's early stumble showed that even the best automakers could struggle with EV complexity. The e-tron story became a wake-up call across the industry. Electric vehicles are as much about electronics as they are about mechanics. And when you mix water with electricity in a 400-volt system, even the most elegant design can end in flames. Number 11. Jaguar I-PACE. When Jaguar unveiled the I-PACE, it was more than just an electric SUV. It was the company's statement to the world that traditional luxury brands could compete head-to-head with Tesla. With sleek styling, instant torque, and cutting-edge tech, it was celebrated as one of the most exciting EVs to come out of Europe. But within a few short years, the I-PACE found itself in headlines for all the wrong reasons. Multiple reports of spontaneous fires. Across the United States and Canada, several I-PACE owners woke up to a nightmare. Their cars had caught fire while charging or parked overnight. Investigations revealed a familiar villain: battery cells supplied by LG Energy Solution, the same manufacturer linked to fires in the Chevrolet Bolt and Hyundai Kona electric. In these cases, the issue centered on internal short circuits within the high-voltage battery pack, leading to overheating and eventual combustion. Jaguar initially downplayed the incidents, calling them isolated and under investigation. However, as more fires surfaced, pressure mounted from regulators and consumer watchdogs. By 2023, Jaguar issued an official recall for over 6,000 I-PACE vehicles in North America. The recall included a software update to improve battery monitoring and prevent overcharging, as well as a gradual plan to replace defective packs. Owners were advised to charge their vehicles outdoors and avoid fully charging overnight. Not exactly what luxury buyers expected from a $70,000 SUV. The recall process itself was slow, with replacement parts delayed and dealerships struggling to reassure concerned customers. The fires severely impacted Jaguar's reputation in the EV market and cast doubt on its long-term electrification strategy. Despite the setbacks, Jaguar continues to stand by its transition to an all-electric future. Newer models are being redesigned with enhanced cooling systems and stricter cell inspection protocols. Still, the I-PACE remains a lesson in how even prestige and performance can't compensate for flaws at the heart of a battery. It's a reminder that when you're building a high-voltage machine, one microscopic defect can destroy years of engineering and an entire brand's trust. Number 10. Nissan Leaf, Early Gen. The Nissan Leaf holds a special place in electric car history. When it debuted back in 2010, it was the first truly mass-produced EV aimed at everyday drivers. Affordable, quiet, and easy to charge, the Leaf helped make electric mobility mainstream. But those early generations also came with serious compromises. And over time, some of those compromises led to dangerous outcomes. Unlike many modern EVs, the first-generation Leaf lacked an active liquid cooling system for its battery pack. Instead, it relied solely on air to manage heat. That worked fine in mild climates, but in hotter regions like Arizona, Texas, and parts of southern Europe, it was a recipe for disaster. Prolonged heat exposure caused cells to degrade rapidly, and in rare cases, to swell or short internally. Several owners reported smoke or small fires after charging or following minor collisions, situations that later models were specifically designed to prevent. Nissan insisted that the Leaf's pack design was safe, and statistically, it was. But the problem lay in aging. As batteries deteriorated, internal resistance increased, making overheating more likely under stress. Combined with the lack of liquid cooling, some vehicles became vulnerable to runaway temperatures, particularly during fast charging or after long drives in high ambient heat. There were no mass recalls, but the few fire incidents that did occur sparked criticism from safety experts. They argued that Nissan had prioritized cost savings over thermal protection. It wasn't until later generations, starting around 2018, that Nissan introduced improved cell chemistry and more robust cooling strategies, dramatically reducing fire risks. Today, the early Nissan Leaf remains a symbol of EV progress and growing pains. It opened the door for millions to embrace electric driving, but it also revealed what happens when simplicity meets extreme heat. In a way, the Leaf's story is less about failure and more about evolution, proof that even pioneers sometimes learn their hardest lessons through fire. Number 9. Ford Mustang Mach-E. When Ford announced the Mustang Mach-E, it was more than just another electric SUV. It was a cultural moment. The company had dared to use its most iconic nameplate on a battery-powered vehicle. And at first, it seemed to pay off. The Mach-E delivered thrilling acceleration, a futuristic interior, and strong sales. But as production ramped up, a wave of troubling reports began surfacing, including incidents of overheating, battery malfunctions, and, in some cases, fires. The most concerning issue involved the high-voltage contactors inside the battery pack. These components control power flow during charging and acceleration, and in early production models, they were prone to welding shut due to overheating. This could cause the car to lose power suddenly, or worse, generate enough heat to ignite nearby materials. Ford initially issued a software update to reduce stress on the contactors, but the problem persisted. In 2022, Ford recalled nearly 50,000 Mach-E units to address potential battery and charging issues. Some owners reported smoke or burning smells during fast charging sessions, while others experienced complete power loss on highways. Although only a handful of fires were officially documented, the pattern was concerning enough to trigger regulatory scrutiny. The recall cost Ford millions and temporarily halted deliveries of one of its most important electric vehicles. Adding to the complexity was Ford's use of LG Chem battery cells, the same supplier tied to previous EV fires in Hyundai and Chevrolet vehicles. Engineers determined that a small number of defective modules could overheat during high-voltage charging cycles. Ford worked quickly to re-engineer the cooling system and battery software, but the damage to consumer confidence was already done. Despite these challenges, the Mustang Mach-E remains a solid performer and a key step in Ford's electrification strategy. Yet, for many early adopters, it was a reminder that even legacy automakers must navigate the volatile learning curve of EV safety. A muscle car reborn as an EV should inspire power and freedom, not fear in the driveway. Number 8. Rivian R1T. When Rivian burst onto the scene, it was hailed as the future of adventure. A rugged, all-electric truck built to conquer mountains, mud, and the open road. Backed by Amazon and Ford, the R1T quickly became one of the most talked-about EVs in America. But with all that innovation came a new kind of challenge, one that literally sparked trouble for the startup. In late 2022 and early 2023, Rivian faced multiple reports of overheating battery packs, smoke, and even small fires involving early production vehicles. These weren't high-speed crashes or freak accidents. They were often tied to internal battery insulation issues and faulty sealing during assembly. Some owners reported a burning plastic smell after long highway drives, while others experienced power failures followed by visible smoke. Rivian's engineers traced several of these cases to inadequate torque on battery fasteners, a seemingly small production flaw with potentially catastrophic results. The company moved fast, issuing a recall that affected over 12,000 vehicles. It was one of the largest recalls for a company so young. Rivian emphasized that no injuries had occurred and that only a handful of vehicles had shown fire risks, but the announcement still rattled investors and customers. After all, Rivian positioned itself as the rugged, reliable alternative to Tesla. And reliability starts with trust. The real challenge for Rivian wasn't just technical. It was emotional. EV buyers in the premium market expected bulletproof quality, especially from a $70,000 truck designed for wilderness expeditions. The idea that an R1T could overheat or catch fire in remote terrain raised serious concerns about long-term durability. Rivian's response was transparent and thorough. The company upgraded its manufacturing checks, reinforced thermal management components, and rolled out new monitoring software that detects heat fluctuations early. While these steps helped stabilize its reputation, the incident served as a stark reminder that even the most promising startups can stumble when mass production meets microscopic precision. The R1T remains a landmark in electric adventure vehicles, but those early fires reminded everyone that when pushing the boundaries of innovation, even the smallest spark can threaten to burn it all down. Number 7. BMW i3. When BMW introduced the i3 in 2013, it looked like something out of a sci-fi movie. Compact, lightweight, and built largely from carbon fiber. It wasn't just another EV. It was a statement of intent. BMW had poured billions into electric technology, betting big on a sustainable, high-tech urban commuter. And for the most part, it delivered. But behind the futuristic design and innovation, the i3 also had its share of fire scares and safety concerns that threatened to dent BMW's reputation for precision engineering. While the i3 never suffered from widespread battery explosions like some of its rivals, early versions of the model did experience a handful of alarming incidents involving smoke and small fires. Many of these cases were linked not to crashes, but to overcharging and faulty battery management software. The early 60 amp-hour and 94 amp-hour battery packs occasionally overheated during fast charging or prolonged high-load conditions, leading to melting components and, in rare instances, ignition. In 2016, BMW quietly issued a technical service bulletin for certain i3s, instructing dealers to reprogram the battery control unit. The goal was to prevent the cells from exceeding safe temperature thresholds during DC fast charging. Some owners in hot climates, particularly in California and southern Europe, had reported battery smells or smoke after repeated charging sessions in high heat. BMW also faced scrutiny for its optional range extender model, a version equipped with a small gasoline engine used to recharge the battery. The additional heat and vibration from the engine, when paired with older cooling systems, caused isolated instances of underbody fires after collisions. Though the company quickly fixed these problems, the image of a smoking eco-car didn't sit well with the brand's clean, futuristic marketing. Despite these hiccups, the i3 remains one of the safest EVs overall, thanks to its carbon fiber chassis and meticulous German engineering. The fires were few and contained, but they highlighted a critical truth. Even the most advanced automakers must respect the volatile chemistry beneath the floorboards. The BMW i3 proved that electric mobility is revolutionary, but not immune to sparks, both literal and symbolic. Number 6. Lucid Air. The Lucid Air arrived with thunderous hype, a luxury electric sedan that promised to outclass Tesla in range, design, and technology. With over 1,000 horsepower and an EPA-rated range topping 500 miles, it wasn't just an EV. It was a declaration that the future of performance had arrived. But beneath that extraordinary engineering lay the same danger that has haunted nearly every electric car maker: fire. Shortly after production began, several reports emerged of overheating, smoke, and even small fire incidents at Lucid's Arizona facility. In 2023, a Lucid Air reportedly caught fire during testing, prompting internal investigations. Later, another fire occurred at the company's assembly plant, this time traced back to battery pack thermal issues. While Lucid emphasized that no consumer vehicles were involved in those early fires, the incidents highlighted just how delicate high-voltage systems can be when pushed to their limits. Lucid's engineers traced the root cause to potential short circuits in the high-energy battery modules. Unlike most EVs, the Air uses an ultra-dense 900-volt architecture, a marvel for efficiency and performance, but also a challenge for thermal control. If even a single cell becomes unstable, the heat can cascade rapidly across the pack. The result? A reaction powerful enough to melt aluminum housings and set off chain fires. The company quickly revised its thermal management design, improving cooling channels and adding more advanced sensors to detect early signs of runaway heat. Lucid also issued service campaigns for specific components, including high-voltage connectors and fuses, to reduce the risk of arcing or overheating. Still, the idea that a six-figure luxury EV could suffer from the same fire anxieties as mass-market cars made customers uneasy. To its credit, Lucid maintained transparency and reinforced its safety image through open communication. Yet the early headlines had already made their mark. A few viral photos of smoking Lucid Airs on transport trucks were enough to dent public confidence. The car's performance remains breathtaking, but its story also reminds us that when automakers push voltage and density beyond what's been done before, they flirt with forces that are literally explosive. Lucid Air may stand among the most advanced EVs ever built, but its early fire scares prove one undeniable truth. Even perfection burns if the chemistry underneath isn't perfectly controlled. Number 5. Tesla Model Y. The Tesla Model Y quickly became one of the best-selling EVs in the world, celebrated for its range, practicality, and impressive acceleration. But alongside its commercial success came a growing list of disturbing headlines. Reports of spontaneous fires that mirrored its sibling, the Model S. While statistically rare, these incidents were often dramatic, spreading fast and burning hotter than most conventional vehicle fires. Several of the most notable fires involved Model Y vehicles that caught fire after collisions, during charging, or even while parked. In one widely circulated video, a Model Y burst into flames in a Toronto parking garage, prompting investigations by local fire departments. The cause was traced to a failure within the battery pack's cooling system. In other cases, wiring insulation and high-voltage connectors were suspected of causing shorts that triggered thermal runaway in the battery cells. Tesla's engineers faced a unique challenge with the Model Y, balancing lightweight construction, high power output, and battery protection. The pack, composed of thousands of 2,170 type cells, is mounted under the floor for stability and range optimization. But in severe impacts, that same location can expose the battery to damage from debris or road hazards. Once punctured, the pack can ignite with ferocity, burning for hours and requiring specialized firefighting foam to extinguish. After several highly publicized incidents, Tesla issued updates to its battery management software to better monitor temperature fluctuations and limit maximum charging rates under extreme conditions. While the company maintained that its vehicles were far less likely to catch fire than gasoline cars, public concern persisted. Owners began asking whether performance-focused tuning and fast charging speeds were pushing the batteries too close to their thermal limits. The Model Y's fire cases also reignited debates about Tesla's build quality and repair safety. Some firefighters complained about the difficulty of accessing the battery compartment, which can reignite even days after the initial fire. Insurance data also revealed that damaged Model Ys were often declared total losses due to the complexity of battery pack repair. Still, the Model Y continues to dominate sales charts, a testament to Tesla's grip on the EV market. Yet its fiery record serves as a reminder that even the most popular electric vehicle on the planet isn't immune to the volatile power source it depends on. Number 4. Fisker Ocean. The Fisker Ocean was marketed as the ultimate blend of sustainability and style, a sleek, solar-powered SUV designed for the modern age. Built by a company that promised transparency, innovation, and eco-conscious luxury, the Ocean seemed poised to disrupt the market. But soon after deliveries began, troubling reports started to surface, involving not just software glitches and braking issues, but something far more alarming: fires. One of the earliest known incidents occurred during testing at a shipping port in California. a Fisker Ocean caught fire while being transported, sending thick plumes of smoke into the sky. The company initially attributed it to a single, isolated thermal event, but further investigations revealed concerns tied to the vehicle's high-voltage battery system. Later, additional fires were reported in Europe, including one in Denmark that destroyed multiple cars at a dealership. Fisker, like many new EV makers, sources its battery packs from major suppliers, in this case, CATL, one of the largest in the world. But experts suspected that the issue lay not in the cells themselves, but in how Fisker integrated them into the vehicle. Improper thermal insulation and inadequate venting may have allowed overheating during charging or under high load. In certain conditions, a single failing cell could ignite surrounding materials faster than the cooling system could react. As the incidents gained attention, Fisker faced mounting scrutiny from regulators and safety watchdogs. The company struggled to provide consistent communication, often releasing brief, vague statements without detailed findings. This lack of transparency angered owners and investors alike. While Fisker later issued limited recalls and software patches to monitor battery temperatures more aggressively, many saw it as a reactive move rather than proactive prevention. The situation was made worse by production delays and financial instability. A startup still fighting to prove itself, Fisker couldn't afford a public relations disaster. Yet the fires did exactly that. The Ocean's promise of clean energy and innovation became overshadowed by fears of unpredictable combustion. In the end, the Fisker Ocean's story reflects the harsh reality of the EV revolution. Good intentions and futuristic design mean little if safety fundamentals are overlooked. A vehicle built to save the planet shouldn't risk burning it, or itself, in the process. Number 3. Polestar 2. The Polestar 2 was Volvo's ambitious leap into the electric future, a car that promised Scandinavian design, solid engineering, and the kind of understated reliability people expected from the brand. Built under Volvo's performance sub-brand, it seemed poised to take on Tesla's Model 3 with a focus on quality and safety. Yet, in a twist that shocked many, the Polestar 2 also faced its share of fire-related controversies that dented its otherwise stellar reputation. Not long after its global launch in 2020, reports began emerging from Europe and China of Polestar, two vehicles suffering from electrical malfunctions, overheating battery modules, and even fires following charging sessions. The first recall affected more than 4,500 vehicles worldwide, and while not all were due to fires, many were linked to faults that could cause thermal runaway. The dangerous phenomenon where a single overheated cell can trigger a chain reaction throughout the battery pack. In one of the earliest reported cases, a Polestar 2 in Norway ignited after the driver had just unplugged it from a home charger. The fire spread quickly through the rear underbody, where the battery pack is housed. Investigators later found that poor sealing around the cooling system and misaligned connectors had allowed moisture to enter sensitive areas, creating a short circuit under specific temperature conditions. Polestar moved swiftly to recall affected cars, issuing both software updates and physical component replacements. They redesigned cooling loops, improved battery monitoring systems, and upgraded insulation materials. But for a brand built on Volvo's reputation for bulletproof safety, even a handful of fires was enough to raise eyebrows. Owners began to question whether early production EVs could truly match the long-term reliability of traditional combustion vehicles. What set the Polestar 2 situation apart was the company's transparency. Polestar communicated openly about the risks and invited regulators to audit its fixes, a move that restored some public confidence. Still, the damage lingered. The idea that a vehicle associated with Volvo's safety legacy could suffer thermal instability was unsettling for loyal fans. Today, newer Polestar 2 models feature far more advanced cooling and cell monitoring systems. But the memory of those early fires remains, a reminder that even brands defined by safety must still battle the unpredictable volatility of electric chemistry. Number 2. Porsche Taycan. When Porsche introduced the Taycan, it was supposed to redefine what an electric sports car could be. Powerful, precise, and built with the kind of engineering perfection that made the brand legendary. With its lightning-fast acceleration, track-ready handling, and gorgeous design, the Taycan immediately earned global praise. But not long after deliveries began, a darker side of this technological marvel started to emerge. Scattered reports of fires that tarnished its otherwise stellar debut. One of the first major incidents occurred in early 2020, when a Porsche Taycan caught fire in a Florida garage, completely destroying the vehicle and damaging the home. The cause was never officially confirmed, but investigators pointed to a potential issue within the high-voltage battery system, specifically overheating during charging. Porsche quickly dispatched engineers to inspect the wreckage, but the company's tight-lipped response only fueled speculation. Over the next couple of years, a handful of similar cases emerged worldwide, from China to Europe. Some fires occurred while the Taycan was charging, while others ignited hours later, long after the vehicle had been unplugged. These incidents were rare, but the combination of lithium-ion volatility and Porsche's performance-focused engineering created a risky equation. With 800 volts coursing through its battery system, double the voltage of most EVs, even a small error in thermal management could have catastrophic results. Porsche's engineering team moved swiftly. They released multiple software updates to refine charging behavior and added more aggressive temperature monitoring to the battery control module. Additionally, they issued recalls in 2021 and 2022 for electrical connector issues that could potentially lead to overheating under extreme conditions. While the company never confirmed a direct link between those issues and the fires, the timing was hard to ignore. For a brand synonymous with precision and reliability, even isolated incidents were unacceptable. Porsche emphasized that EV fires were statistically rare compared to gasoline vehicles, but the image of a smoking six-figure Taycan spread fast on social media. Insurance companies took notice too, with some increasing premiums for electric sports cars due to their repair complexity and fire risk. Despite these setbacks, the Taycan remains one of the finest electric vehicles on the market, a masterpiece of performance and innovation. Yet, its story reveals a paradox shared by all high-performance EVs. The more power you pack into a battery, the more you flirt with danger. When the pursuit of speed meets the limits of chemistry, even the best-built machines can turn combustible. Number 1. Tesla Model 3. The Tesla Model 3 wasn't just another car, it was a revolution. Compact, affordable, and packed with cutting-edge technology, it was the vehicle that truly brought electric mobility to the masses. But behind the incredible sales figures and glowing reviews lies a troubling reality. The Model 3 has been involved in more publicized fire incidents than any other electric car on the road. From California to China, Model 3s have gone up in flames under every imaginable condition. After high-speed crashes, during charging, while parked in garages, and even spontaneously while sitting idle. In one particularly shocking 2019 incident in Shanghai, security footage showed a Model 3 suddenly erupting into flames while parked, sending smoke and fire throughout an underground lot. Tesla's local team blamed the issue on a single battery module failure. But the images of a burning Tesla spread across the internet faster than the fire itself. The problem, as experts have noted, lies in the car's densely packed lithium-ion cells. The Model 3's battery contains thousands of small cylindrical cells tightly grouped beneath the floor. This layout offers remarkable energy efficiency and power delivery, but creates an environment where heat can spread quickly if even one cell fails. When thermal runaway begins, it often leads to chain reactions powerful enough to melt aluminum, burst into open flames, and reignite multiple times. Tesla has long argued that its vehicles are statistically less likely to catch fire than gasoline cars, and that's true. However, when EV fires do happen, they're often far more intense and difficult to extinguish. Firefighters in multiple U.S. states have reported that Model 3 fires can take over 20,000 gallons of water to fully cool, and that smoldering battery packs sometimes reignite days later. To Tesla's credit, the company has implemented several preventive measures over the years, including improved battery insulation, cooling systems, and constant monitoring through over-the-air software. Yet, critics point out that software can't eliminate the fundamental risk built into lithium-ion technology, especially when performance and efficiency are prioritized over redundancy and safety margins. The Tesla Model 3 remains the best-selling EV in the world, a technological triumph that changed the automotive landscape forever. But it also symbolizes the double-edged nature of progress. The same innovation that electrified the industry has, at times, quite literally set it on fire. It's a stark reminder that in the quest to dominate the future, even the brightest sparks can become dangerous flames. Electric vehicles are transforming transportation, but as this list proves, even progress has a dangerous side. From luxury sedans to affordable compacts, no manufacturer has been entirely immune to the risks that come with high-energy lithium-ion batteries. While EV fires remain statistically rare, their intensity and unpredictability make them headline news every time one occurs. These aren't simple engine fires. They're chemical reactions that can burn for hours and reignite days later. The good news is that every incident pushes innovation forward. Automakers are now investing heavily in safer battery chemistries, like solid-state and sodium-ion designs that virtually eliminate thermal runaway. Improved cooling, smarter software, and stricter safety standards are reshaping the next generation of EVs. The electric future isn't just about going faster or farther, it's about making sure that clean energy doesn't come with a hidden cost. Because true progress isn't measured in miles per charge, but in safety per spark.